something like that, and here's the resultant vector. This is 80. What's that angle right there? 150. The angle between them was 30.
Sure, my face can't be seen.
That is clearly not 30. So it's got to be the supplement, which is 150.
I run an anonymous account, clearly.
What could we do now?
A squared is equal to...
The law of cosines. Law of cosines to find the length of the vector. They want us to find the angle, but we do need the length of the vector to be able to get the angle, because we would then do law of sines. So law of cosines to get the length of the vector, law of sines to find this angle right here. Is that our answer? No. Because what angle are we trying to find?
30.
Yeah, we're trying to find the angle with the x-axis. We're trying to find that. So we'll find the black angle, which I would guess would be pretty small. And then we'd subtract it from 30, and that would give us the orange angle, which is what we're looking for. Does that make sense?
Yes.
Is that good enough? Or whoever was asking?
Yes.
Okay. Anything else? So the first part, few parts, was not too big a deal. I will tell you that in 3 classes today, I did not have one question on anything before 59. So, must have done okay on that then. Cool. All right. This is a big day. Because we get to start the final section of the year. Oh, no, you like 8.7. We're about to start 8.7a, and tomorrow we'll do 8.7b. And then we will be done.
That kind of scares me.
Well, think of it this way. You have, as of tomorrow at 2:42, you will have learned all of Algebra 2 and all of Pre-Calc. I know.
That's
In 1 year.
weird. That's a weird notion.
In one hectic, stressful, I don't know, year.
Yeah.
Yeah, horrible.
But one of the things I told you in August, I told you this in August, I said when we get to May, you will be ready to take AB Calc. And at this point, you are all ready to take AB Calc. Okay? And you'll see that. You'll see that when you walk in the door in August. Hopefully, the same door. Hopefully.
Is there summer work?
There is a summer packet. I was just talking to Ms. Ruelas about it during prep. I would do it towards the end of the summer to try to kind of re-stimulate the mind a little bit. It's online. You find it online.
Do you know when they're going to put it online?
It's online.
Really?
Mhm.
Oh.
It's always online.
They never
Because
take it off.
Oh, I haven't found it.
Yeah, you gotta. It's academics.
Summer positions.
Or you can just search summer projects.
Search summer packets, something like that. Yeah,
Huh.
it's there. It's always there. So
Oh.
that hasn't changed at all.
Maybe I'm dumb.
The fact that you guys are asking about that is pretty cool. I think. Anyway.
I think I'm just
So-
being... What are we on? Point.
Ready for the last topic? Last
That's what I
section. I'll tell you
I kind
that
of have anxiety, but that's
today's gonna
Same.
look this. If you walked in and the board was full of the stuff from the previous class, you'd get very stressed. And by the end of today, you won't think too much of it at all. Okay? So, trust me.
Begins crying.
Let's call Z1 4 times the cosine of 40 degrees plus I sine of 40 degrees. let's call z sub 2 3 times the cosine of 20 degrees plus I sine of 20 degrees. What they are going to ask us to do at the beginning of this section is to simply take z1 and multiply it by z2. z1 and z2 are, what? Nope.
A dot product?
Polar form of what?
Imaginary complex numbers.
Complex number. Yeah. z1 is a number. z2 is another number. And all we're going to do is multiply the numbers together. So to be able to do that, because it's a little weird, we need a formula. So here's our formula. If z1 is equal to r times cosine of theta plus, r1, sorry, cosine of theta 1 plus I sine of theta 1. And z2 is equal to r2 times the cosine of theta 2 plus I sine of theta 2. Then z1 times z2 is going to be r1 times r2 times the cosine of theta 1 plus theta 2 plus I sine of theta 1 plus theta 2. And it looks like a mess, and if you think about it for a minute, you can describe what we just did in English. In order for us to multiply two numbers in polar form, comma, we need to,
Two different R's.
what do we do with the r's?
Multiply the R's and
Multiply
add
the r's
And
and add the thetas. That's all. So to multiply two numbers in polar form, we multiply the r's and add the thetas. So back to this problem. z1 times z2 would be 12 times the cosine of 60 degrees
plus I sine
plus I sine of 60 degrees.
That's a lot less messy.
That's not that bad, right? Issues with what we did. Multiplied the r's, added the thetas. If they ask for our answer in polar form, we are done. That would be it. Polar form, 12 cosine of 60 degrees plus I sine of 60 degrees, done. If they ask for the answer in rectangular form,
We're not done.
simplify. So 12 times 1/2. Cosine of 60 degrees is 1/2.
Oh, square root of 3 over 2.
Square root of 3 over 2i.
And then plus
And then,
what?
well, we already did that. It's 60 degrees, so it's first quadrant.
6.
So now what?
Distribute.
Distribute the 12, which gives us
6
6
plus
plus
6 root 3.
6 root 3i. And there it is. That would be our answer in rectangular form. Make sense? Questions? What do you think we're going to do next?
Z3.
Let's say that z sub 1 is 12 times the cosine of 162 degrees plus I sine of 162 degrees. And z sub 2 is 3 times the cosine of 42 degrees plus I sine of 42 degrees. Matt thinks that they're going to ask us to do Z1 divided by Z2, which is exactly what they'll ask us to do. Now, I feel very strongly that knowing what you have learned in the last 5 minutes, that you could give me the formula for Z1 over Z2. So, tell me,
R1
Divided by
R1 over R2,
times the
cosine of
theta 1
theta 1
minus theta 2
minus theta 2
plus
plus I sine
theta 1 minus theta 2.
theta 1 minus theta 2. And I was correct. You could do that. Came up with your own formula. That's perfect. That's perfect. There we go. That's better. So what is Z1 over Z2? 4 cosine of 120 degrees
Plus I sine of 120.
plus I sine of
120 degrees.
120 degrees.